I'm going to show you two ways to do this question. The solutions way, first of all, which is really nice. So we can add on some of the side lengths. So the square has side length 1, so this is going to be 1, 1, 1, and 1. But not anymore at the moment on the perimeter. Now let's say, all right, this is half of the diagonal. Okay, so I'm just going to call this S, and therefore that is also S. And we can think really carefully about some of the other things. So this here is also the diagonal because it's half of the diagonal because it goes from the center of this square to here. So this length is S, and that means that this length here is 1 minus S because the full length is 1, the half diagonal is S. And so I'm going to get the same over here as well. And this is really nice because we can just add these up. The S's are going to cancel out because I've got 2S and I've got minus 2S. So I just need to add all the ones together. 1, 2, 3, 4, 5, 6. And that's the answer. Okay, really nice. I didn't actually do it like that. I figured out what S was, and it doesn't matter because it ends up cancelling, but I just didn't think to to write it like this. So what I did is, again, I said 1, 1, 1, 1. Then I figured out what this must be because we have a right angled triangle. 1 by, hold on, let me just look at it a sec. So that's 1, that's 1. Oh, okay, sorry. The hypotenuse of this triangle is 1. And then I'll call it S for the moment. So then we get 2S squared using Pythagoras' theorem is 1 squared. So S squared is a half, and therefore S is 1 over root 2. In fact, this is a useful result to know. Whenever you have like a right-angled isosceles triangle, whatever you have as the hypotenuse, you just divide it by root 2. So if this was x, this would be x over root 2. Okay, so now I see that I get 1 over root 2. I get 1 over root 2. I'm still going to fall back to looking at this and realizing that it's 1 minus 1 over root 2 and 1 minus 1 over root 2. So I've just put in more effort, really. At the end of the day, we're going to add these up, and these are going to cancel, and we're still going to get our answer of 6. But, this is still a solid method, and, along the way, you actually calculate what this part of it is. But ultimately, they all cancel out.